Yeah. Now is it audible, sir? Good morning. Good morning. Okay. Thank you, sir. Because sorry for the delay, dear participants, because due to rain actually and power cut at my home, this was a little delayed, but I'll continue up to at least 12:15 or 12:30. No issue. Right. Thank you. Yeah.
My dear participants and today's resource person, a very good morning to everyone. Welcome to the final day of our FDP, Artificial Intelligence, Machine Learning, and Data Science with Research Applications. So it's my great privilege to read today's resource person profile. Dr. ILAIAH KAVATI is an assistant professor in the Department of Computer Science and Engineering at the National Institute of Technology, Warangal, India. He holds a PhD in Computer Science and Engineering from the University of Hyderabad, awarded in 2016 for his research on efficient indexing techniques for biometric systems. He earned his MTech and BTech degrees at Jawaharlal Nehru Technological University, Hyderabad, and a diploma in ECE from Government Polytechnic College, Warangal. Dr. Kavati brings over 13 years of teaching and 5 years of dedicated research experience, having previously held faculty and research positions at institutions such as IDRBT, MLRID, and Anurag Group of Institutions. Research interests lies in biometrics, image processing, computer vision, blockchain, IoT, and deep learning. Currently guiding 13 PhD research scholars to supervise numerous postgraduate and undergraduate students projects. Our has several chapters published by the on work platforms like work violence detection and bio blockchain authentication framework and AI-driven transportation with academic excellence. Dr. Kavit is active on national mission first parallel and is engaged in research on trusted identity security and blockchain para parametric and academic to applied AI and secure systems. Design continues to drive impactful innovation in both academia and real world technology.
Yeah, thank you, madam. Thank you for the nice introduction. Very good morning, dear participants. Am I audible, madam?
Yes,
Is play this camera? Just just a minute. Actually, I'm trying, but I don't know why it is not working. Just a minute. I'll no, no issue. Just a minute. Just a minute, sir. Yeah. Am I visible, sir? Now? Okay. 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 Sorry for the delay. Just I'll share my content. Okay. Yeah. Is my screen visible, sir? Yeah, thank you. Oh, thank you. Yeah, thank you. Yeah, thank you. Okay. Right. Okay. Very good morning, all of you. Right. My session today is on like biometric template security. Uh, Basically, biometrics. Actually, I start with what exactly biometrics and what are the different research challenges and what exactly we are doing as of now. Right. So coming to biometrics, right? Uh, Generally, wherever we go, people will ask like, "Who are you?" Right? uh, Suppose if I want to enter some private area or public area, people generally the security personnel they'll ask produce your identity, right? Just a minute. Produce your identity, right? So traditionally we'll use our ID cards are some password-based mechanisms, right? But they have few limitations like ID cards may be stolen or passwords may be you may forget like passwords. So basically, biometrics they are with us, and no need to remember or no need to carry. Am I audible, sir? Am I audible, sir? Hello,
Yeah, sir.
hello.
Hello.
Am I audible, sir?
Yes, sir. You are audible.
Okay,
Yes.
right. So. Right? So wherever we go, people will ask us to produce some identity, right? But these ID cards or password-based mechanisms have some limitations. So that's why biometrics are generally people like suppose if you see nowadays Aadhaar is everywhere, like to get ration or to enter into some airport or wherever we go, we are producing Aadhaar, right? So biometrics are like they are with us, and we cannot carry or we cannot remember like traditional based mechanisms. But they themselves, like suppose coming to biometrics, they themselves are prone to attacks. Like someone may forge your biometric, or someone may forge your fingerprint, or someone may forge your face, like using some photo or video or some mask like you, and they can access your private places, right? Or means your nowadays basically, if you see everyone is having many suppose if you see many bank accounts, social media accounts, right? Suppose if you observe like SBI, ICICI, and multiple accounts we'll have, like our salary account one, and our personal account like one, and the social media account, Facebook, Twitter, all these, right? So if our password or something is compromised, if someone access our password, someone hacks our password or this thing, so they will enter into our world and they can do damage, right? So to address this, basically we can use biometrics, but biometrics also, as I said, that people are what they are used, means they are making like spoofed or synthetic fingerprints are like this. Suppose in our institute also for biometric attendance purpose, we are using biometric attendance. But what students are doing, they are creating their synthetic fingers and they are asking their friends to present their fingerprints in their absence actually. They are asking their friends to present their synthetic fingerprints to get the attendance, right? So maliciously they are like they are getting attendance without their presence. So they are bypassing the system, like they are biometric system, right? So recently you can see last 1 year back I read one article in Yusufgura or some place in Hyderabad also, one of the contractor, like sanitary contractor, what he did, one of the sanitary contractor, under him there are 100 daily wage employees, and for each of them he's paying, like government is paying 500 per day, and totally 15,000. 500 means 15,000 per month. 100 employees, but what he did, the sanitary employee, he created some synthetic fingerprints of these employees, and daily 30 to 40 these workers are attending the duties, right? But the attendance he is marking for 100 employees. 30 to 40 only attending the duties, and 100 employees, he is presenting the biometric of 100 employees because he created synthetic fingerprints. So at the end of the month, everyone is getting 15,000. So for government, it is 15,000. It means totally 15 lakhs amount. 15 lakhs, 15 lakhs amount are crediting to the accounts of different employees. But later, what they are doing, actually these 30 to 40 workers are attending. Remaining, they are doing other jobs. Right, but so what they are doing after getting their salary, they are depositing half of their salary to this salary contractor. So 15 lakhs means half of the salary of them means it is around 7.5 lakhs. And as is a contractor, is politically sound, and he's not having any educational background, but he's making money like 7.5 lakhs per month. See, without having any, like us, any qualification. See, because what is happening here, they are fooling the biometric system, right? So actually, what I said, so to address the limitations of traditional methods like I said that ID card based mechanisms or password based mechanisms. So we are using biometrics, but what is happening here? They are fooling this biometric system also, right? By presenting synthetic fingerprints. Let's say, suppose in online meeting or wherever, instead of presenting our live face for getting attendance or to enter in access some resources, instead of presenting my live face, if I present my photo, what will happen there? Or someone who maliciously wants to access my resources, instead of present on my absence, what they are doing, they are presenting my photo or video, right? So this will bypass the system and they can do the damage, right? So this is the main limitation of these biometric based systems, that is they are prone to attacks. So my topic, like how we can address that, we'll discuss, right? This is the first challenge. Basically, So the first one is what? Tax over biometrics, right? Now coming to actually biometric systems working, there are two types actually. That is verification and identification. Everyone knows, like those who are working in JNTU affiliated colleges, because everywhere biometric attendance is there, right? So there are verification and identification. So whatever it may be, but both of these mechanisms works into like this. First, there will be registration phase, right, followed by either verification or identification. I'll tell you like what exactly this one. So during the registration phase, so there will be a sensor, like suppose if you want to capture our face, there will be a camera, right? So it will capture our face. So biometric capturing, that is image or biometric capture, followed by, this is the first step, right? Followed by some after capturing this, we have to store somewhere, like in a database. So captured, suppose Aadhaar, take Aadhaar. So while registering, we have to present our 10 fingers and face and 2 iris, right? So like that, the biometric will be captured and stored in some database, right? So with our ID, let's say some ID, like every faculty will have some ID, right? JNTU ID or something. So like that, our ID and corresponding biometric will be stored in the database. Right now, I'll tell you one reason. What is a problem with this? Let's say if someone access the database and use this biometric for some malicious purpose, means your biometric is compromised. They can use it for any purpose. Like as I said, they'll take your face, like your stored raw image, and they can use, they'll present to some other application, and they'll get on behalf of you, they'll get your ration or your pension or your whatever it may be, right? So this is a main limitation. And as I said, like suppose traditional systems, ID cards or this thing. Let's say if your ID card is, you lost your ID card. What you'll do, you'll go to admin office and you'll ask to produce a new ID card. They'll issue by charging some 100 rupees or without charging also, right? So you are getting a new ID card. Like if you think that like your password is compromised, like if you once you open your Gmail, right? In your send box, you can observe without your knowledge, someone sent a message. Means your password is compromised. Someone accessed your or your Facebook account. You see nowadays there are multiple people that creating, but that is not the case. I'm not saying that case. Creating a fake account. I'm not saying that. But if your password is compromised, someone will access your social media account and they may post some malicious messages. Like they may ask money, or they may send some false messages, like to uh, uh, you know to damage your faith or something. What they will do, they will post some malicious or illicit messages, so that damage your faith and your image in the society, right? So these things will happen. Now assume some, without your knowledge, someone posted or someone sent some message. So what you will do, that means your password is compromised. So what you will do, basically, you'll if you observe that, you'll click on forgot password and you can get a new password. So if your ID card is lost, you are getting a new ID card. Your password is compromised, you are getting a new password. But assume your biometric is compromised. Someone captured, like someone accesses the database and they are using your biometric for malicious purpose. So you came to know that someone is misusing your this thing. But how you'll get a new biometric? See, we have limited fingerprints, 10 fingerprints, one face, and two. Let us assume your face is compromised. Are using face biometric. Your face image, like they are using for malicious purpose. How you'll get a new face, right? So with ID, you are getting a new ID card. With password, you are getting a new password. But with your face, you get a new face if it is compromised. No, right? No, that is not possible because every human has only one face. So again, this is the problem with biometrics, right? So this damage actually can happen because this database exists at some remote place, like a remote server, right? So suppose let us assume our JNTU also everyone is presenting that, right? But the remote server will be somewhere else. So during this at the consumer side, at our customer side, we have a sensor to capture the device. But this authentication process, like whether he is a genuine user or not, whether he is belongs to a minority faculty or not. So what it is doing, it will the server at the server side, this comparison is happening, right? So during this process, capturing it the consumer side, customer side, and this biometric we are sending to a remote server. So the security personnel, right? This there is a chance of this man in the middle attack also, right? Means there is a chance of compromise. There is a chance of accessing our biometric during transmission. During transmission from customer device to the server or at the server. At the server means at the storage. So I want to say here, see, this is the process. This may happen in transit or in storage, right? In storage or in transit. So during transmission or at the storage. So how to address this issue? So this is one issue, right? So here I'm saying so we need to provide some security to the biometric image, whatever capturing at the client side or customer side. So that is called biometric template security. So what I'm going to address. Right. So this is one topic. And the next one, as I said, we are getting a new ID card and we are getting a new password. But what about our face? Once it is compromised, we cannot use it, right? So we need to have such mechanism. So what exactly we are doing here? We are cancelling the old one ID card case. We are cancelling the ID card or password. We are cancelling the old one and we are issuing a new. Cancelling old and issuing a new ID or password. So we need to have the mechanism for biometrics also, right? So we need to cancel the old template I'm saying, right? So old template and we need to issue a new template for biometric also. If we are storing our raw face or raw biometric, this problem is happening. So if we have a mechanism if we extract from this biometric after biometric capture, if we have a mechanism some template generation process. Template generation means see whatever image processing, after capturing the image, first we'll extract the features. That is called feature extraction. So I can call it as feature or a template. Okay, so the features will suppose my face features the different landmarks of the face. Suppose if you see the fingerprint, different fingerprint consists of set of ridges, complete ridges, right? So you can observe the fingerprint. Suppose if you see the ridges, it will consist of some ridges, right? So these ridges, from these ridges, they will extract some features. Those features are called minutia features. So one ridge suddenly bifurcate into two ridges. It will split into two ridges. Just I think I have some slide here. Yeah, you can see here. See, suppose somewhere here, this ridge comes like this, and it is bifurcated into two ridges. So this point, you can see here, this point is called a bifurcation point, or merging point, or bifurcation. Bifurcation means it is the ridge is bifurcated into two. Like that, somewhere here you can also observe. These are all minutiae features. Like one ridge is bifurcated into two. You can also see here. Somewhere here, right, and somewhere here. So these features are captured somewhere here, right, and somewhere here. This is one bifurcation point. This is one bifurcation point. You can also observe the corresponding this particular position. This one. So what we'll do, instead of storing this raw fingerprint in the server or database, we'll extract the features like this. These features, the spatial coordinates, actually the spatial coordinates. So suppose this is x-axis and this is y-axis. So the position of this and the orientation of this. See, the orientation, if you observe, the orientation is like this. But for this minutia point, the orientation is like this. For this point, this is the orientation with respect to x-axis, right? And for this is the orientation, and this is the orientation, right? So the spatial coordinates, that is x comma y position, and the orientation, that is the angle theta. As well as there are not only bifurcation, there are other minutia points also will be there. Like this is a core point. See, you can observe here, this is called a core point. So we have different types of features like core point, delta point, and we have bifurcation, as I shown, like, and we have endpoints. Endpoints means actually here not shown basically, where the endpoint means where the ridge suddenly disappears, right? But if you see these ridges, this ridge disappears here, this ridge disappears here, this ridge disappears here, this ridge disappears, right? So these are the, but this is due to cropping the image, or due to while we are presenting our fingerprint on the sensor, because only that touch area will be captured, remaining complete fingerprint like will not be captured, right? Because we will present just straight our fingerprint. But if we present rolled fingerprint, so we can capture. But that's why here basically people will use these points, and these are contributing very less endpoints, because they are due to cropping our fingerprint, right? So if we suddenly, suppose if the cropping mechanism is like this, so all these ridges will suddenly disappears. So all will becomes endpoints, but they are really not the endpoints. So that's why we will not consider this. And one more important thing is core and delta also, for all the humans it will not be present, right? Some human beings will not have this core point and delta point. So that's why basically people will use only these bifurcation points. So what I mean to say here, instead of storing the raw fingerprint here in the server, what we'll store, like these features, or we'll call it as a template. The features extracted, like these x comma y and this theta of these bifurcation points, will be stored in the server in some binary format. Because x comma y, suppose this, if you see this maybe, suppose assume this is 0 0, right? This is 0 0, and on the scale this may be like suppose assume this is 80 on the y-axis and 10 on the x-axis. So the position is 10 comma 80. and that orientation is, suppose, let's say, it is mm, some orientation like this is uh, some 60 degrees, right, with respect to x-axis, because this is like this, right? So with respect to x-axis, so the angle is maybe 60 degrees, right? So this particular information will store in the database in digital form. So that is called, see, fingerprint minutia features, as I said, right? So these minutia features are encoded as a binary template and will be stored in the database, right? So instead of storing the raw fingerprint. But what happens, from the features also, someone may draw, like someone may sketch your fingerprint. See, recently that Pulwama that attack happened, right? So the witness persons, like they said, the features of that terrorists. So the sketch artist, from the features we can generate the face also, face or fingerprint or anything. See, in many movies also we'll saw, right? We can see like some criminal activity, something happens, some theft or murder or something. So the witness persons, police people will come and they will ask like what are the features, like what is his hairstyle, what is, yeah, recently, this Saif Ali Khan's house. See, some theft was happened, and immediately within hours they can get your face. So same thing is happening here also. This was proved actually in through research. Like from the features, they are getting the raw image. Right? So where is now biometric security? Like where is our security to our face image? Because if they get our face, then they can use it for malicious purpose. If they get our fingerprint, they can use it for malicious purposes. So that's why this template security is important, right? And what I said, let this is compromised. Then how to generate a new template? Okay, so the first area, like we need to provide security to the biometric template. Let's say you are providing security, right? Then anyway, these hackers, these malicious persons, always comes with new ideas to break our system. See, we'll generally assume we'll write, like we'll develop a new cryptographic or crypto, our what is that called, or a new algorithm like RSA or encryption algorithm. Always the attacker comes with so always the attackers comes with new ideas to break the system, right? So simply they'll they'll decipher or decrypt our this thing, and they may use for malicious purpose. So no, there is no, see, whatever may be the technology, always it will be they'll come up with new ideas to break the system, right? So let us assume your encrypted or protected this template is compromised. Protected template is compromised. Then how to generate a new one, like our ID card and our password. See, we are providing security to the template, but still, see, there are different phases. We are not initially, we are storing what I said, the raw biometric image. But if it is compromised, you cannot use it for other applications, or because they may enter into your world and they can do the damage. So that's why instead of storing raw biometric, what we are doing, we are storing the template. But from the template, as I said, the raw image also they can get it. Right? So we need to have, see, the phases, the raw image. From that we are storing the features. But for features, For the features, as I said, they may get the reverse engineering like raw image. So what we are doing, the next phase, we are providing security to the template. But let us assume this is compromised. Then how to? We cannot reuse it, right? So we have to cancel it like our ID card and password. We have to generate a new template. So that is called cancelable biometric. Right? So these actually we have discussed attacks over biometrics initially, right? Like they may present your fake or forged. This is about forged case, and this is about during transmission or during storage. They may compromise your biometric. So we have to cancel it and we have to generate a new one. So this is cancelable biometric. This is spoofing or forged case, and to secure our biometric, we need to provide some secure mechanisms to protect our biometric. So biometric template security, attacks over biometrics, cancelable biometrics, right? So these are the cases we are going to discuss. And one more first case, template security. And cancelable biometric. And we need to identify whether that is a real or spoofed. Right? And now I'll tell you, like as yesterday I started with verification and identification, right? So two types of biometric systems, verification or identification. So registration phase, as I said, first image capture, capturing image, then feature extraction, because you cannot store the image as it is, right? So feature extraction, then these extracted features will be stored in the database with some security, like okay, this is general phase. This is registration phase. So now how it is storing with our ID, we'll say our ID and our biometric face features or features will be stored. Secured, like encrypted features. Now during verification is one where the user claims his identity. I'm so and so. I'm Dr. ILAIAH, right? Or I'll produce my ID number like 762. So then in the database, all our samples will be registered, right? So with our ID number or our some username or something, right? ID. So at the time of verification, we are claiming like who we are, right? They will ask, the security person will ask, who are you? Then we'll say, my ID is 762. Myself, that's ILAIAH. Then they will ask us to present our biometric, right? So now we'll enter our ID and we'll enter our ID and present the biometric. Now using this ID, our record will be fetched because already registered user, right? Our record will be fetched and the presented biometric. Professor. Hello, Professor. Session loan on master 12:15 okay. So I'm saying my ID is 762 and I will present my face or fingerprint. Right? So the features will be extracted And as I said, like, so I entered 762, right? So my features will be extracted from the database, and these features and these features will be compared. So then, if both features are matched, you are a genuine user. Now tell me, some other person, some ex person comes and they'll enter my ID 762 and they'll present this malicious face, his face, his or her face. So his or her face, the features will be extracted, right? And from the register, as I already registered, right? So from the database, those features will be fetched and compared. Now tell me whether those her features and my features will match or no. No, right? So she will be rejected. So this is actually called identification. Just there is a one-to-one match. So I'm entering my ID, and my features, only my features will be fetched. So there is a one-to-one match. Now the second case is identification. Like in identification, let's say they will not claim any identity. Like suppose a crime. What happened? In the identification phase, suppose let us assume a crime incident happened somewhere, right? So they will not say any identity, right? But this investigation or the forensic people will come and collect some evidences. We have a database of means entire Indian, population, right? But who did this particular, whose fingerprint or whose face is this? How to identify? Because they are getting in the verification case, what happened? They are saying who we are, and the system is comparing with one-to-one. But here in this case, only that we have the evidence. The criminal don't say like his ID number and who exactly he is, right? Only this evidence will be there. Now, how to identify this particular person? So we have a database of n users, right? So ID1 and his features, ID2 and his features, ID n means suppose let us assume our college itself, some where CC camera is not there, and some incident happened, and these some evidence these forensic people collect, and how to identify. Even our college also almost will have 5,000 to 6,000 persons. So the traditional case is what? First we have to compare this evidence with first user, then second ID, then third ID, then fourth ID, like that. The worst case complexity is order of n. Right? Best case maybe one, average case maybe half, right? But worst case complexity is order of n. If n is very big, and assume each comparison takes a millisecond, right? If we have the population of India more than 100 crores, right? So each comparison will take millisecond. Then order of n case it may take days, right? So meantime he may leave the country or this thing. So how to address this, right? So that is we need to prune the database. So the concept is here is called like our indexing mechanism, DBMS indexing mechanism, biometric index. But again, simple this RDBMS concept will not work here, because at the time of registration, our features like our face may be straight, but while doing this criminal activity, I may not present my straight face, right? that it may be my side angle, or with I may have some specs, or I may have this beard, or different. I may wear some mask. Or, these a lot of things will be happen. Then tell me, see, these features and these features will not match, right? So this is actually called, these issues, a lot of issues will be there. This is called intra-class variation. Both are my faces only, but collected at different instances. Collected at different, at the time of registration, it may be different. At the time of this identification, it may be different. Because of age, because of light conditions, or because of camera quality, different things will be happen. This is called intra-class variations. Sometimes my face features may be overlapped with some other person. Then innocently, like he may be arrested, or on behalf of the criminal, or that particular person. See, there may be overlap. The feature overlap may be there, right, between different users. So that is again called interclass similarity. Interclass, different persons may have similarities. Right. So that's why, see, creating a unique index for the user is difficult, because see, at the time of registration, my face is straight, or maybe a clear face. But at the time of doing this activity, that may be low light or night, that different. So the features may not match. So based from the features, we cannot generate a unique index for the user. So simple. That's why, see, in RDBMS, what we'll do, simply we'll have a key, primary key, or foreign key, or these keys will be there. Based on the key, we'll fetch that record. But here, unique key is not possible. It means that unique index is not possible, right? So again, this is an issue. Anyway, now these are the different issues actually, and here one more concept actually, these partial fingers, because at the time of collecting evidences, see, only partial, suppose knife, observe knife, or some surface like wall or something, just they can collect only partial evidence, like partial fingerprint or this thing. Then it is difficult, right? So these are the different cases where we can work in this particular area, like biometric security, right? So these are the different areas you can work. So traditionally, for all these, this template security, cancelable biometric, real spoof, or putting the databases, all these things, simple image processing based methods are there. But nowadays, everywhere, this AI ML, like AI based techniques, ML DL based techniques are using, and they are everywhere, they are they are more accurate than this traditional based mechanism. So that's why actually I did my PhD with simple image processing based methods only. But later, anyway, after 2018, 17, 18, 19, more this machine learning, deep learning mechanisms everywhere, like in every field people are applying, right? So we are also currently working with these particular DL based mechanisms and ML based mechanisms, right? So this is a biometric template, right? Okay, and so I'll focus purely on these three topics, right? So as I said, if we store raw biometric, what people are doing, maybe forged, or it may be captured by someone, right? So instead of that, what we are doing, we are storing the features. But what is happening, the features, from the features they may get raw the image. So security we are providing, right? But even though if we provide security, they may compromise it. So whatever the mechanism we are providing here, it should follow these three properties. See, what is happening here from the features, they are doing the irreversibility. Means the reverse engineering. They are getting the raw features, right? So it should not be happened. Right? So the first property is irreversibility. Whatever the mechanism, whatever the model or whatever the technique we are providing, it should not be irreversible. Like one way. See, the template, from the template we cannot get back the features or raw image. Features. If we get the features again, we can get the raw image, right? So this should be a one-way function, like our hash. But again, hash will not work in image processing. Not only biometric, hashing mechanisms. Hashing is one way, right? So hashing functions will not work in any image processing, right? Basically, biometrics, because see, as I said, at the time of capturing, my face is different. At the time of verification or authentication, my face will be different. Face features. So hashing mechanisms, if one bit change, even one feature or one bit in the plain text, if it change, it will create a new hash. Those hashes will not match, right? So that hashing mechanism, avalanche effect, people, that, right? If one bit change also, it will not, the hashes will be different. So that's why, see, if I apply, like while registering my my features in the database, some mechanism I'll apply, like let's say hash. That is hash one, because based on my features at the time of registration. But at the time of authentication, my features will be different. Some features will be different. So I will get a different hash. These hashes will not match. Right? So that's why these hashing mechanisms will not work in our case. So that is the first property. So that is difficult to reconstruct original biometric data from the protected template, irreversibility property. Now, revocability, right? If compromised, as I said, if compromised, anyway, if compromised means that protected template itself, people can capture and use it for malicious purpose again. And you came to know that your template is compromised or used in malicious purposes. Then what you will do, basically, like your password is compromised. Assume what you will do, even though your password only you knows, but what attacker will do, will try to get with the different techniques. There are many techniques. In the next slide, it is there. What are the different techniques to? So, if compromised, assume if compromised, then how to generate a new one? Generate a new template. That is revocability. Like cancel the old one and get the new one. And the third one, this is important again, unlinkability. As I said, interclass similarities in the previous slide. Exactly it. This is intra-class variations and interclass similarities. Multiple persons, like different persons may have feature overlap, right? So leads to what? This person may be identified as that person, right? This incident happened, recently with Saif Ali Khan incident, that theft incident. Some Bangladesh guy actually did that. Means the police people caught the Bangladesh guy, but he's not the person. Unnecessarily, for 7 days or 8 days, he was under custody, and damage, like damage happened, but he's not the real person because of feature overlap. So some other person did with big hair and this thing, but the person who were caught, he's having less hair, but face features are similar in some side angle or right. Later, police people recognized the real this person, but anyway, the damage happened, right? See, his societal these things are damaged, right? People will think that but he is not the person. Right. So this interclass similarities creates a lot of issues in biometrics. So this unlinkability, that means no, we are generating a template, right? Protected template. So that template should not, two different persons should not have the similar template. Right. So that is unlinkability. That is prevent cross matching like Saif Ali Khan case. Right. Should not be matched with other persons. So these are the three important properties. Any algorithm, like whatever the model we develop, that should follow these three characteristics. Yeah, any questions, please? Now we'll enter into actually the topic. These are the different research challenges, right? So if you have any questions, please ask. Any questions, please? Am I audible, sir? Hello? Hello? Any questions, please raise your hand, or I can directly ask, or you can post. Okay, so this is the system architecture. Like during enrollment, this biometric will be captured, right? And we'll extract the features. So we will generate a template that is in transformed form, like one-way transformation. It should not be irreversible, right? And we will storing in the database. Now, during identification, let's say identification or verification, what we are doing, again, we are presenting our to get attendance or to enter into your social media account. What you are doing, you'll present your face or your fingerprint, so that you can access it, right? So the features will be extracted, template transformation, then it will be compared with the registered template, right? If that is matched, then you will be authorized to access the system or whatever it will, right? Else, otherwise, some other person, some malicious person, on behalf of you, if he present his face or something, it will be rejected. So this is system architecture. So these are the different types of attacks, as I said. So spoofing is the first one, and the replay attack. Replay attack, like they may capture in the middle of the man in the middle attack, right? So they can use like your features for malicious access. So how we can address how we can address replay attack is based on timestamps. We can have some timestamp. So if it is latter present, if someone present some after some time, so there will be timestamp, so it will be denied. So right, so replay attack we cannot. So hill climbing, hill climbing. What is hill climbing attack? He'll repeatedly tries. So start with you know uh, some trial. Later he will improvise that one until he succeed. He will change the template, right? So finally he may succeed or not, but he will try. Like hill climbing, in Bahubali movie, he started with small steps. A lot of times he'll fail, but finally he'll succeed, right? So like that, hill climbing, we may not succeed in the first attempt, right? So similar this thing. Denial of service. This is again important. Let's assume some person is getting pension. So the pension, basically nowadays this pension or ration purely based on Aadhaar and is biometric. Someone intentionally changes is encrypted template or protected template in the database. Intentionally changes. See, my template is modified in the database. Some bits, because it is stored in the binary form, some bits are altered. My ID is there 762, but my data is modified, encrypted, whatever it may be. Now, if I present my biometric to get ration or to get pension, those stored template, because it is modified, now not matched with my presented features. Correct or not? So the genuine person also may not get the services. Right? So this is called denial of service. Even though he is genuine, means denial of service in security is different. The flooding attack and these things will be there. But here, denying, the genuine person is denying from getting the services. Why it is happening? The malicious person intentionally is doing that. And these are the attacks over database. Already we discussed, right? Attacker steal or modify template to gain unauthorized. See here, what he will do? He will completely change my template with his template on behalf of me. Now what he will do? He will present his fingerprint, right? And he say his my ID number 762. He'll present his fingerprint, but already in the database he modified. In my at my record, what he did, changed, he modified with his features. Now anyway, he is not a genuine person, but he will be recognized as genuine user, right? So this is different. To gain unauthorized access, he may steal or he may modify the template, right? So these are the different things. Now for this biometric template protection, these are the different mechanisms. That is feature transformation, as I said, template, secure the template using some transformation, one-way transformation, right? So under this, we have some sorting concepts and cancelable biometrics. And someone may ask, like cryptography, why can't we use simple cryptography, right? So at the time of storing, store them in encrypted format in the server. So encrypted features, right? So the server at some remote place, right? Now at the time of authentication, you will present, and this will be encrypted, and these features will have to be decrypted, and it has to be compared. But during decryption, again, the decryption leads to what? Or they'll get the raw features, right? From the features, we cannot trust the at the server side also. The attacker can access, right? So there is no privacy, correct? From that decrypted features, because they are in raw form now, they can get back. They can get the original fingerprint or face. So this is the limitation with crypto systems, and this is one limitation, right? And next, to address this particular issue, actually homomorphic encryption will be there, where there is no need of decryption. So this will allow to match in encrypted domain, encrypted format. Means the registered template will be encrypted, and the presented at the time of authentication, this will be encrypted and will be transmitted to the server side, and both will be compared in encrypted format. So this homomorphic encryption will allow to match. So there is no need of decryption. So privacy will be ensured, and there is no chance of getting back the raw images, raw fingerprint or raw face. One more concept is there, like visual cryptography, where actually the image will be, yeah, see this image, suppose if you see the biometric input will be divided into multiple shares. Let's say this is share 1 and this is share n. Here I am showing only 2 shares, but n shares we can create, and this n shares actually not segmenting the image in the grayscale or in the RGB intensity. Will the grayscale intensities or RGB these values will be divided into shares. Let's say grayscale. Suppose let say here each pixel in grayscale will be in the range of 0 to 255, right? Each pixel. Let's say one pixel is the pixel intensity is 100. Pixel intensity is 100. So it will be divided into multiple shares. Let's say 20, 20, 60. In one share, the intensity of this pixel will be 20. In another share, it will be 20. In another share, it will be 60. This is uneven distribution, some based on some weights, or we can have equal distribution like 33.3, 33, 33, not 3, 33.3, 33, 33, 33, equal shares. So a pixel with 100 intensity in the main image will be divided into in the different shares. This is another image, this is another image. The share of that pixel in this image is 33, in this image is 33, and third share is 33. Right? So divided into shares. The image is divided into shares, and each share will be stored in different servers. See, earlier what happened, the captured image, the features or whatever it may be, stored in single server. If some attacker, access that server, right? So enter or the fingerprint or the face, whatever it may be, they capture it. But now what is happening, instead of storing the image in a single server, we are dividing into shares, and each share we are storing in different servers. See, what is the main idea here? The attacker may access one server, but may not access multiple servers at the same time. Right? To get back this image, he has to access multiple servers, and he has to combine all these. Right? So possibility is less. So that's why. And one more important thing is that each share, after creating the shares at the client side, it will be transmitted using different channels, not the same channel. So follows a different channel and stored in different servers, different channel as well as servers. Now, at the time of verification, see here, this is at the time of authentication, I will present my fingerprint, and from the servers now, see here, like this share will be accessed and this share will be accessed, and we'll do some XR operation or combining mechanism to get the target image. Right now, this image from the server, from the storage, and this presented image will be matched to get whether I'm a genuine user or not. So only thing here is that instead of storing in a single server, that is single point of failure, centralized systems, we are storing in some distributed, like multiple places, and at the time of verification, we have to get those shares and combine them to match with the scheme. So this is visual cryptography scheme, right? And there are other mechanisms like hybrid methods, combination of all these crypto systems with cancelable biometric, homomorphic encryption, or visual cryptography, all these things. So this is hybrid methods, and this is most important, steganography and watermarking. So steganography is hiding the secret in a cover, hiding the secret in a cover. What is secret here? The biometric, because we need to provide security to the biometric, right? So hide this secret. Secret means biometric in a cover. See, suppose let us observe while we are sending, like while we are preparing question paper to hand over to the exam branch, what we will do, we'll put all those question scripts, like question paper scripts into a cover, and we'll fold it and we'll punch it or we'll paste it, right? And we'll hand over to the examination branch. So inside that, the secret is there. What is the secret? The question paper, right? But to the outside world, people can see only that cover, right? So same thing here, to provide security to the biometric, so we can embed, we can hide, or we can put that biometric into a cover image here. Cover means here in our terminology, this is again an image. Okay, so biometric is an image, so we'll hide our biometric into another image, right? So this is steganography. Just this is the example. You can see this is a cover image. No, there is no hidden information, but this is the same image with some hidden information. In our case, this is hiding something, like hiding the secret or embedding the secret into a cover image. So this is called steganography, right? So you can observe to the outside world, they can see only this scenery, flower image, but inside that there is a secret. Basically, this will be used not much in biometrics, but this is will be used in military communications and medical, no, telemedicine nowadays, right? So medical applications, everything is, after Corona, the medical reports or whatever it may be, they are nowadays online. But if someone, that information is disclosed to someone, what will happen? His health information will be leaked, right? So that again leads to privacy problems, right? So that should be hidden. So that's why nowadays this is this particular technique, like steganography, people are using, like for military communications and medical application. Someone may ask, why can't we use these techniques in military application, biometric crypto systems or feature transformation or these things? Digital cryptography anyway can use, but if some plain text is encrypted, how are you? Let's say, if it is encrypted, how are you? Plain text is some meaningful, but if it is encrypted, this may lead to some XYZ, ABC, some random form, meaningless format. If some message is in meaningless format, generally, the attackers, as I said, they'll get mental, like until decrypt it, they'll try like anything, right? Finally, they succeed because they'll have, always they come up with new ideas, as I said, right? Their only duty is to decrypt it, right? So if it is in some random format, meaningless format, they'll try to decrypt it. But see, if we apply this particular technique, people may ask, suppose, let's say, by hiding some secret into that, I'll send this message, this image to you by saying like good morning. See, no one will get doubt, right? So this is the way we can use this thing. Any questions, please? Right. So now we'll see different mechanisms, uh, how we can have template security and cancelable, like once compromised, how we can cancel the old one and generate a new one, right? So the first method you can see here, we're capturing an image. The image is encoded, like generally, image is in two-dimensional format, right? So we'll have this X dimension and Y dimension, right? So what we'll do, we'll convert it into a 1D vector where, the rows and columns will be there in an image. So what we'll do, we'll convert it to a 1D vector, right? So then here they are using some elliptical cryptography mechanism, ECC encryption mechanism, because this is lightweight compared to our RSA or DES or these things, right? So this whatever the 1D vector will encrypt using this ECC based mechanism. Now this is the encrypted 1D vector. Then what we'll do, we'll report again, like converting the 1D to 2D, because after encryption this is 1D, right? So now again we'll encrypt, recode it to a two-dimensional space like an image. Then we'll do a normalization, because this normalization is important. As I said, an image consists of the pixel intensities between 0 to 55. Suppose let's say some pixel of intensity 150, if it is encrypted, it may lead to some value which may be greater than 255. Suppose let's say if some number like 10 is encrypted using RSA, right? So that encrypted value may be maybe 10,000 or 15,000 or 1 lakh or whatever based on our key, right? So the value will be rather than 255, means not in the range, the encrypted values are not in the range of 0 to 255. So we need to normalize those values. Okay, normalize means this min-max normalization will apply. Suppose if we conduct exam for 200 marks, at the time of giving grades, like we need to normalize the total marks to 100, right? So similar normalization process will apply here to have in the range of 0 to 55, because image should be represented in the range 0 to 55. So this normalization will do. Then the image will be enhanced. Then we'll give the this normalized images to the CNN model for training and testing, right? So then you can detect whether that is a genuine user or not. But only the way here is that we are providing security to the template, like we are encoding it as a 1D vector and we are encrypting with the encryption based mechanism, right? Simple, some converting it to ciphertext, right? And we are recoding it as well as we are doing the normalization. See, those whatever may be the range, we are normalizing. Now getting back the original features, like here, original image is difficult because we are encrypting it as well as we are normalizing it, right? So this reverse process is not possible. And in case, let us assume this encrypted template is compromised, we can generate a new key for the user and we can have a new encrypted vector, that is new template. We are cancelling the old one, right? And we are generating the new template using a new key, right? So like this, we are protecting the template. Even in the case of compromise, we are generating a new template for the user using new key. Right? So this is the way we can have this cancelable metric. Let's say this is a finger wear image, and these are the grayscale, converting the RGB image to grayscale, right? And this encoding scheme, actually we have used this direct encoding. Let's say this is a 3x3 image. Let's say this is a 3x3 image. So what we are doing, a row concatenation, row by row concatenation. See, this is 132, 131, 128. This is first row. Then this is the second row. This is an example. 3x3 image will not be there, but we're explaining means understanding the concept is taken like in 3 by 3 image here, right? So first row followed by second row and followed by third row. And here to have this irreversibility property, this is somewhat we can have again if we arrange them as two-dimensional, again we'll get back the image, right? But anyway, we are encrypting it followed by normalizing it, right? So not possible anyway. But to have more, security, like we are also following this LBP encoding, where if you observe here, this 3 by 3 image, right? So for this, the center pixel is encoded as 210. 128, the center pixel intensity is 128. It will be encoded as 210. Check how. See, with LBP based mechanism, how it will works, the center pixel is compared with its 8 neighborhood, right? So 8 neighborhood means, this is first, second, third, fourth, fifth, sixth, seventh, and eighth. So this 128 is compared with 132. If the current pixel is greater than the center pixel, right? This current pixel is greater than center pixel, it will be assigned with 1. See, 132 is greater than 128, then it will be encoded as 1. 131 is greater than 128, it will be encoded as 1. 128 is equal to 128, that's why it is encoded as 0. Now, likewise, 125 is less than 128, it will be encoded as 0. 123 less than. So, like this, now the different pixels will be given the binary values based on this LBP encoding. Now, the center pixel is encoded like by considering these pixels in this fashion. 1250. 1250. Right. So now you can observe this 110 followed by 1000, 110, 1000, 10. Right. Now this is encoded as 210. 128 is encoded as 210. So right. So some mechanism instead of encryption or this thing. Now the pixel intensity, the value, that particular value is encoded as 210. Is it possible to get back 210 from 128 from 210? Not possible, because see, same case I'll explain with one more. Suppose there is a pixel with intensity 10 and its neighboring pixels are 11, this is 12, and this is 8, and this is 9, and this is 11, this is 8, and this is 9, and this is 19, and this is 5. Now this center coded as, this is 1, as 11 is greater than 10, 1, 12 is greater than 10, 1, 8 is less than 10, 0, right? So just see this scenario. Now 17 is encoded as 1, 8 is encoded as 0, 9 is encoded as 0, 19 is encoded as 1, right? 5 is encoded as 0. Now just check 110, 110, 1000, sorry, 100, 10. See, this 10 also encoded as now 210. Now, see, for the same, see, this is a combination, it's possible, right? So, any pixel, like means multiple pixels may have same encoded value. So, that's why getting back from the 210, now if we reverse it, will we get 128 or will we get 10 or some other value? I'm not sure, right? So we may get any value. So reversibility is not possible. So this is irreversible. So that's why this is one scheme we have used. See, the pixel intensity is 14 is encrypted as 1022. As I said, it should be between 0 to 255. Right? So that's why again, what we will do, this is 1D vector, one dimensional vector. Then we'll recode it as 1D to 2D like this. Then we'll normalize it. See, normalized because the values are out of range, 889, 889. See, 297. It should be less than 250, less than or equal to 255. So this is valid values, but all these are not valid values. So we have to normalize. So after normalization, this is the values, and this is a different image with these intensities. And now this is the normalized image. You can see rich texture is there, right? Now these are some enhancement techniques, like the image may have some noise, right? So we'll apply some enhancement techniques. Then give it to the model for training. But as this image, we fingerprint data set, at that time we have very less images. But to have to train with a deep learning model, we need to have more data. So we did some augmentation, like flipping, cropping, and rotating, and these things to have more data for training. Because see, as I said, at the time of registration, my face may be like this, but at the time of authentication, my face may be in different pose, right? So we need to train the model such different poses, right? So that's why what we'll do is during augmentation, we'll rotate image, we'll crop image, we'll flip image, right? We'll do different type of geometry transformation, and we'll train the model, right? So that at the time of authentication, it will be easy for the model to identify or classify the particular person, right? Uh, And see, as I said, also compared with different mechanisms, RSA. What is RSA? Public key encryption mechanism. But basically, we have used elliptic curve cryptography because that is lightweight. Now, the accuracy of the model is 97.17 with RSA and direct encoding, means not LBP. So LBP direct encoding is a little bit not that much secure, right? But with this, we are getting 97.17, but this is a heavy model, right? So it will require a lot of computation to generate the key and this encryption process, right? Now we compared this model with our results with uh, RSA and direct encoding. This is 97.17, but with LBP, you can see 92.45. The CIR stands for correct identification rate. RSA with the correct identification rate with LVP encoding, right? 92. There is a drop of 5%, right, in the performance. But the only advantage is that means 5% okay, but we are providing more security. Right? That is the concept here. And now ECC and ECC with the direct encoding, you can see 94.34, whereas here it is 97. There is a drop of 3%, but this is lightweight model, which can be used for customer devices, right? Anywhere like edge devices or this thing, because the servers exist at some remote place, right? So client side we have limited computation. So that's why this is important. So these are the results, right? And one more mechanism. This we use it for iris template protection, iris images, right? Here the basic mechanism is that these first two steps are common for any iris-based mechanism, that is segmentation and normalization. See, while capturing the iris image, so there may be chance of these eyelashes and this all complete eye will be captured, but this actually this iris will have a rich texture, and that important information may be missed if we capture the entire image. So that's why we have to segment that iris. Means we have to remove this unimportant portion, and we have to concentrate only that iris portion, right? So removing these eyelashes and all these things, right? So that is called segmentation step. Then after segmenting, the after iris segment, the iris will appears like this, some elliptical or egg structured format. But this will not be an image, right? So we have to convert this into a rectangular format, right? So segmentation will segment our iris portion, right? Then the normalization will be converting this elliptical structure to a rectangular format, like image format. So these are the compulsory steps for iris based authentication mechanism, right? So that's why here we have some ready-made tools to do these two steps, segmentation and we have used the same thing. Like we have some rubber sheet model, Dugman's rubber sheet model, or recently there is a toolkit called IIT Delhi Iris Toolkit, which will give us these ready-made normalized images for iris images. So if we present our iris to this toolkit, it will give us this rectangular format. So this is the image, converting the iris into rectangular format. See where this rectangular portion is visible now here, right? Not visible, correct? So only we are able to see this rectangular format. But elliptical iris is not there, right? Because we are converting into a rectangular format. So one of the normalized image is the rectangular strip of the iris. So one of the most common ways is Dugman's rubber sheet model. So we have used that, but as I said, there is a IIT Delhi's toolkit also, which is more, generates optimal rectangular strip, means more accurate. Then this normalized image, what we'll do to protect this template, whatever this thing, we'll use a base 64 encoder, right? So to convert, irreversible format, right? Convert protection and irreversible. The first property is irreversible, right? So we have here in the previous also, as I said, see, irreversibility is there, right? Sorry, irreversibility we are ensuring, as well as cancelability, like revocability. So reversibility is there, revocability. If it is compromised, we can have a new key, and we are getting a new template. So canceling the old one and getting the new one, right? And this cross matching attack, because for each user, we may use his means random key is based on his metadata. We will create some key, so the encrypted template will have different because based on different keys, right? So the cross matching also, yeah. So like this, the second case, see base 64 encoder, the first property we need to achieve is irreversibility, right? So for irreversibility, what we are doing here, converting this normalized image, right? We have the intensities between 0 to 255. We are converting into the format of 0 to 63. Base 64 means, so those intensities will normalize to 0 to 63, right? Then actually 63 and will convert the image intensities. These are numerical values. So this is the interesting concept here. Numerical values to text. Numerical values to text. See, image means we'll have intensities, right? So those intensities we are converting into text. So from that text, we'll extract some features, right? Then we'll use a model for training and classification. We'll do like identifying or verifying a particular person. So this is the first step, converting into rectangular strip, and the base 64 encoder. You can see base 64 means simply the values in the range of 0 to 255 are normalized between 0 to 63. Like as I said, suppose if we conduct exam for more than 100 marks, suppose 150 or 200 marks. So at the time of awarding grades, what we need to do? We need to scale down or scale up. Suppose if we conduct exams for 20 marks, we need to scale up for 100, right? Into 5 we need to do, right? So like that scaling operation will do, so that now the intensities are between 0 to 63. Now these numerical values, like suppose 0 to 63, these indexes 0 to 15, 16 to 31, 32 to 47, and 48 to 63. These are the encoded values, right? Encoded numerical values. they will be converted into text. Like this 0 is converted as space. Text includes, text means sentences, words like this, right? So two different words will be separated with space, right? So 0 is encoded as space, and index 1 is encoded as capital A. So like this, suppose index 1, 2, see index this, yeah, A, B, C, D, E, right? 15, and see 26 is encoded as Z. 25 is encoded as y, right? So like this, so 0 is encoded as space, and 1 to 26 are encoded with capital letters, and 27 to, see here, 52 are encoded as small letters, and 53 to 62 are encoded with numerical numbers, that numerical values, that is 0 to 9, and 63 is encoded as dot. No sentence, different sentences can be distinguished with dot. Different words can be separated with space. So simply the numerical values we are converting into text. See, this base 64 encoder. Now you can see these values are encoded as text. Sorry, these the intensities are encoded as text. Now see, this text is meaningless, random. Right now, from this text, is it possible to get back, the intensities? Maybe possibility is there, because we scaled down 0 to 55 to 0 to 63, right? So that's why what we'll do, we'll extract some features, like from 25 or 26 different features from this text. Like, see, this text is meaningless, like random, right? So how many words are there in that particular image? How many capital case letters with respect to the total text? How many capital letters, right? How many sentences, average sentence length? How many average word length? Like this, 26 different features will extract, right? So from 17 methods, we'll extract 26 language independent features, because there is no meaning, right? So every language will have some syntax, but this is syntaxless, right? No syntax is here. That's why language independent features, we call it as language independent features. And see, these are the different features, like average sentence length in the text, percentage of capital letters in relation to number of lowercase letters, percentage of lowercase letters in relation to the total number of characters. So like this, see, these are the 17 different methods. Number of words occurring twice in a text, number of words occurring only once in a text. So like this, now you can see 13th method, the number of words of a given length, number of words of given length in a text. That means 3-letter words, 4-letter words, 5-letter words, 6-letter words, number of words, like 7-letter words. And next 14th method, you can see the number of words whose lengths are within a given range. That is 3 to 8. Actually, this one mistakenly 3 to 3, 3 to 8, 3 to 9. Like the total words, like whose length is 3, 4, 5, 6, 7, 8. So combining the words with this range, 3 to 8, words with 3 to 9, words with 3 to 15, the number of vowels in a text. See, these are the different mechanisms actually we have used. Even I cannot get what exactly this one. I'm not explaining, but the concept I'm giving, right? So from these 17 methods, see here, this is 12 plus this is 5, 12 plus 5 plus 3 plus 2 plus 4. So 12 plus 5, 17, plus 3, 20, 22, 26. Total 26 features for each iris image we'll extract, and we'll give it to the model for training and classification. See, this is a feature extraction method, and we'll use different models. Actually, this was not published, that's why I haven't uh, given the results here, right? But anyway, so irreversibility we are achieving, right? And one thing I have missed here, like before base 64 encoder, we have incorporated a key-based mechanism for transforming this thing. Again, I skipped this because this was not published. So, so in case of compromised, so we'll change the key so that a new template will be generated for the model, sorry, for the user, right? So anyway, based on key, we are having the template, right? So cross-matching attack also will address. Cancelability is there, revocability is there, and as well as this cross-matching attack also are addressed. So this is this one, and the other one directly I will go to the next concept. See here, this is a here in the case here this is multi instance iris. So this is the left iris. Both iris will capture left and right, and we'll do some cross folding. The combination of this. The combination of this, like see, first we'll generate a random matrix such that it will consist of all ones, zeros, random matrix, right? Now this will be multiplied with this left iris. So if we multiply something with 1, so we'll get something that x. But if we multiply with 0, it will be 0. Right? So the left iris, wherever 1 is there, the left iris intensities will be captured in the cross-folded image. Means we'll have that left iris images. Now during for right iris, what we'll do, we'll complement this matrix. That means this 1 0 becomes 0 1 0 1 0 0 0. Now this with complemented, this is binary matrix B, random matrix 1 minus B. This is complemented, right? Now, yeah, what do you want? ఎప్పుడు తీసుకున్నావు ఎవరు దగ్గర తీసుకున్నావు ఇప్పుడు వచ్చేది మరి ఇప్పుడు అవ్వదు ఇంక ఇది నేను ఎప్పుడో మెయిల్ పెడితే ఇంకా అవ్వలేదు జస్ట్ 10 minutes అవ్వదు సో దిస్ రైట్ iris now will multiply with this complemented or inversed matrix, right? So now see in the case of left iris, as this is the left iris intensities are preserved for these ones, right? Now this is complemented. Now at these complemented places we are having 1, right? Now here in this portion, this right iris intensities will be preserved, and this completely this is fused to get a cross-folded. Right now, is it possible to generate? See, get back the original iris images. Not possible, because to get that we need to have that random matrix first, random original matrix, right? If we have the random original matrix, then we'll have this inversed one and we'll get back. But it is not possible to get this random matrix, so we are ensuring this cross-folding mechanism. Anyway, the segmentation, as you can see, finding the inner and outer boundaries by eliminating these things, these slashes and these things. Actually, that is, the slide was I need to put there, but okay. This is one more mechanism you can see, where this left iris and right iris actually multiple experiments are done here. So we will extract the features using this deep learning model. So right, then the extracted features are of this size 1:256. Then we'll use some random projection as some user key, right? Then we'll generate a matrix of 4x4 actually. Then this will be converted into one-dimensional vector, that is 1x16. Now this 1x256, that is 256 cross 1 will be matrix will be multiplied with 1x16. Now we'll get a final matrix of 16 cross 256, right? So this actually the logic will be here, right? So now the original features will be projected into different domain, right? So that is 1 class to 56. We are now getting 16 class to 56. That will be stored in the database and see used for training and classification. So at the time of verification, similar step will follow. Like for left iris and right iris, you can see we are extracting 1 class to 56 features and we'll do the random projection, same thing, and we'll fuse these two things, and we'll get this thing, and we'll give it to the model for classification, right? So now the user will verify, means classify to whom this particular iris belongs, right? So in the case of verification, as I said, the user will also provide the ID. So based on that ID, it will verify like whether that belongs to that particular user or not. That is verification. Verification means what? Whether the claimed user is genuine or not, right? So this is verification, right? So this is a network, deep learning network, and this is a fusion-based, cross-folding-based mechanism. And as I said, now again, it's reversibility. This say to reverse, like to get back this 1 class to 56, we need to have this orthogonal matrix. But this is based on our user. That will be known to only the user. So the irreversibility is not possible, right? And the revocability, in case if it is compromised, the user will give you a new key, right? So he will get a new template, right? So cross matching also, we are ensuring that this is based on the user. So like this, we can ensure protecting the templates. Yeah, any questions, please? So this is about template protection and cancelable biometric. But as of now, actually, we are working in different areas like like the liveness detection. This initially I said, right, spoof detection, real or spoof detection, right? So this is the this is one work. Any questions you can post meanwhile. See, this is that work, face anti-spoofing, right? So this was submitted to this journal, like International Biometrics Behavior and Identity Science, and 2 revisions over. Now this is under minor revision, right? See, gradient reverse, right? So you can see here, like how the systems are. See, this is a real face, right? This is a real face. I don't think this will be right. This is a real face where a real face, the biometric system is a lock, right? So we are unlocking it, right? It's accessing, right? We are entering into the, but with fake, with photo also, they are fooling the biometric system. This is unlocked, right? There is a lock, right? But that is lock means that is a biometric system. They are unlocking, right? These are the different types of attack. Real photo attack. This is a real face, but photo attack, video attack, some masks and these things, right? Video వీడియో ఉందా నాకు పంపించగలరు so for that actually we did like this work and see how this is original face and these are the fake faces, fake head, glasses attack, replay attack, and the paper mask attack, and these are the different attacks actually. So this model actually is able to identify the forged regions using our model. We have I have actually this real-time implementation also we did where we can use for face anti-spoofing, because people are, even my students, in the last semester we have introduced this biometric based authentication, but they are asking their friends to present their biometric on behalf of them, on behalf of their absence actually. right? They are getting attendance. So one day I observed, and see why people are there around 70, but students, 90 students are getting attendance. Yeah, our classes are actually large classes. So 90, 85 students are getting attendance. If I count that, there are only 70 students, right? Or 60 students, but the student who is absent is getting the attendance. One day I asked, so what is happening? So they said intentionally they created some synthetic fingerprint. In the beginning, I said, right, the contractor example. So same thing was happened in our institute also. Means this is the problem with the spoofing, right? So that's why we have come up with an idea like I will show you this video once. చాలా రోజులు అయిందండి వీడియో మా మీడియా ఎక్కడ ఉంది
మీడియా సార్
ఓకే ఓకే ఓకే
మీరు ఆల్రెడీ డౌన్లోడ్ చేసి
డౌన్లోడ్ చేస్తాను ఇదమ్మా పంపిము పంపించా సెండ్ అవ్వలేదా సెండ్ అవ్వలే ఓకే ఎనీ క్వశ్చన్స్ ప్లీజ్ పోస్ట్ ఇన్ చాట్ బాక్స్ మీ మన డ్రైవ్ లో ఉంది కదా కరెక్ట్ right, so you got it. Just see this. So how our model is able to detect this spoofed or forged faces, and it is able to differentiate with live and this is real face. You can see in the side angle also it is showing like this is real face. So real face. Now just I'll see real glasses and these things, and this is spoof. You can see this is a printed photo. If we present it to the biometric system, it is saying this is spoof. This is also spoof. You can observe spoof mask. See, someone may have your mask and they are present, right? See, we experimented with the different these things. This is full mask, and say this is cut photo. See, in the low light blur condition also, as this is a real face, it is showing real, right? Because the environmental conditions are very important. Blur face, complete blur, but it is saying this is a real face. Light blur, low light condition, different conditions we have experimented, right? Now you can see low light, complete light is not there, but it is saying real. See, even the background, like other person came, just check background clutter, but it is saying this is a real face. So this is very, very important nowadays, right? Because see, on behalf of someone, others are getting the benefits, right? So that's why we have come up with this thing. So if you have any questions, please ask. We are సరిపోయింది. Kiran sir, if you see if any questions, please ask them like to post in the chat box and they can ask.
Participants, dear professors, do you have any questions? Please ask. Do you have any questions? Please ask through the chat box, or you can raise your hand. We will enable your mics. Dear participants,
So this is another one, like you can see for face forgery detection. So if no questions, then we'll wind up the session, sir.
if you don't have any questions, means we'll wind up the session. Dear participants, please, if you have any queries, please ask sir. Sir is ready to give solutions for your questions. Dear professors, do you have any questions? Please raise your hands, or you can ask through the chat box. Okay, sir. Then they don't have any questions, sir.
Yeah.
So we can wind up the session, sir.
It's
Thank
okay,
you, sir.
Thank you.
Yes, sir. Thank you, sir. Thank you so much for the knowledge presentation. Your presentation was both insightful and engaging, and it truly enriched the knowledge of everyone who attended the session. And we look forward to having more such sessions with you, sir, in the future.
Yeah.
And thanks for accepting our invitations and giving this knowledgeable session, sir. Thank you so much.
Welcome, sir. Thank you.
Yes, sir. So, dear participants, we'll have a session at 1:30 p.m. Please stay back. And we'll start the session by 1:30, and we'll close the session by the 3:30 p.m. followed by the valedictory session. So thanks for your patience and cooperation. And we'll share the both the forenoon and afternoon session feedback link after the valedictory session. Thanks for your cooperation. Happy learning. And my humble request is don't leave the session. Stay in the session. We'll start the session by 1:30 p.m. Thank you, one and all.